Introduction to Testing of Materials. It's a course devoted to engineering students or engineers. I'm formerly a professor of Jadavpur University, Kolkata, India. And the course starts with lecture 1. First, we will see what is a material and what is a testing. A material is a 3D object having length, breadth, and height. The piece of material can be a metal, ceramics, or a polymer, which is known as plastics. And what is testing? Testing is measurement of mechanical properties of materials. What are the mechanical properties? Mechanical properties are related to the resistance of materials against application of external force or load. Because in every applications, we use a force and load on a material. So, material has to resist that load. So, we are interested to understand how much load or a force a material can withstand. This is for our design purpose. And from that, we choose the material. First, we see what is the common mechanical testing. It starts with hardness testing. It's the empirical form of testing which men are using for time immemorial. What is hardness? Hardness is resistance against indentation. What is indentation? Indentation is like pinching nail over the surface of material. Or when we drive a nail on a wood, it indents the wood. Similarly, a material can be indented. A notch can be created. There is very small size of a notch, and the resistance of the material against this notch is generally known as indentation. And the hardness number is arrived at from that indentation. There are a number of hardness numbers in different form of testing. For an example, Brinell hardness test, Vickers test, Rockwell test, short-cellular scope test, like many things. If we use our own fingernail to indent a wood surface, you will see probably a scratch can be found out. But if we do the same operation on a piece of stone, we will see this is not happening. So our conclusion becomes that wood is soft, stone is hard. Similarly, case of metal, metal is also hard. And it is a kind of hardness which determines that which material can resist large amount of or high amount of external load. Now, this is an empirical test, meaning that it develops by observation. But with time, with improvement of design, man wanted to know more theoretically valid strength testing. So we come to the most important mechanical testing, which is known as tension testing. Tension testing means resistance of the material against tension load. What is tension? Tension is simply pulling. When you pull a wire, when you pull a man by hand, it is a tension. It is a very, very important kind of load which totally identifies the importance of material. Why steel is so much used in construction of buildings, bridges, equipments, everywhere you will see steel, 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 steel. Why? Because steel has a very well accepted resistance against tension load. Now, we will discuss in detail when we come to the chapter of tension testing. But for just interest, how we can know that what material will give us good resistance against tensional load? This is measured by yield strength of the material. Yield means that is it loses. For an example, when you in a debate you yields to the logic, that is you accept it. So the maximum resistance of the material against that tensional load. It may be ultimate tensile strength, it may be fracture strength, or this type of number of parameters that you will determine in tension testing, and we will understand which material is very good for tensional load. And we will see again then the steel is very good in tensional resistance against tensional load. Stone is not that much, brick is not that much, even plastics is not that much. So this will come when we come to the chapter. Next important mechanical testing is impact testing. There is resistance of the material against impact load. What is impact? Blowing the face of a man by your fist. This is sudden, this is very temporary, or striking a cricket ball with your bat. A fraction of a second is ball in contact with the bat, but it is an enormous load which puts the ball away from the field in boundary, over boundary like that. It's a very important kind of thing because many material are resistive to tension load, but it cannot encounter the impact load. And so we have to think about this impact testing. For example, steel. Take the case of steel. Steel you can see in every bridge, in car, in ships. But if you put that bridge or car or the ship in sub-zero temperature, it acts like a brittle glass. So a man, when he uses the steel, he should be aware that even at the low temperature or a sub-zero temperature, in the icy condition, the steel can be used. And that is measured by fracturing a 10 by 10 by 55 mm V-notch sample. The small sample, almost length of your finger, square section 10 by 10, and its length is 55 mm, around 2 inch, and at the center there is a V notch of 2 millimeter depth. And when we break it by a hammer, it absorbs some load before fracturing, and that is known as resistance against fracture. And this energy absorbed is a criteria for understanding impact resistance. This is a very important kind of test, particularly in modern field, because man is continuously using low temperature for different use in freezing, in transportation of ships through polar areas, icy conditions, in fact. So when we go to that chapter of impact testing, we will discuss this. And most of the common test procedure is the now internationally accepted is Charpy test. Next, we come to the creep testing. What is creep? Creep means simply slow moving over the surface. In earlier test, whether it is hardness, whether it is tension, whether it is impact, the time is not considered. But now in creep testing, we must consider the time. When you put a material for a long time, for example, take the case of your bridge. A bridge is kept for a long time, or a wire rope in which you put your load, where a ropeways, you put load for a longer time, in months, in years. In that case, you will see material extends itself under the load, particularly tensional load. And the resistance of the material against constant load with time is measured in creep testing. So what is creep? Creep is a time-dependent strain at constant load or constant stress. Stress is a new term you are getting. We will discuss it when we come to the tension test. And is generally measured by a parameter known as creep strength. That is 1% strength in 10,000 hours against a given constant load or stress. You will see, particularly in the airplane, we are using too much airplanes nowadays. Some parts is moving at a high temperature. So at the high temperature, when the parts is moving, it creeps. That is, it increases its size. Now it totally disrupts the mechanical systems and may lead to a failure. So whenever we are using a component in a aircraft, we must be aware of how much creep resistance the material is. Many materials are very good in normal transport or road transport, but at a high temperature and with a constant load, this material can break down very easily. And particularly our Boeing plane, you will see the previous material was a steel blades. Now it is replaced by the nickel alloy, high nickel alloy, which is known as super alloy blades, because it has got a large grip strength over steel material. And so creep is a time dependent property. Here the second factor, the time or the second, comes into the picture. So this is creep testing, and we will see how have to test creep properties. All these you use static load, whether hardness, whether tension, whether impact, whether creep, we use static load. That is, load is static. But in actual practice, when you move a motor, electrical motor always rotates something, a shaft. And this shaft, one portion of the shaft is fixed in a bearing. So the shaft in the rod always subjected to cyclic load, which is known as dynamic load. That is, load is dynamic. That is, load is one time increases in one part, decreases immediately in that portion with time. Again it is coming to this high load, again it is going down to the low load. So fluctuating load condition, even a bridge, when cars or trucks or heavy trucks move over the bridge is under the influence of fluctuating load. One time the load of the bridge is going to 10,000 tons, and as soon as the truck passes, it comes down to 5,000 tons because that heavy truck has already passed. So this is a fluctuating load, and it is dynamic load. Whether you want it or not, we have to move a material. We have to move in a shaft. We have to move a machine. We have to run our air conditioner. We have to run our fridge. Everywhere, a system, we are using a moving part. So a moving part is under the influence of dynamic load. And here we want to know what is the endurance limit up to which we can use it. And the endurance limit is found out from a fatigue testing. That is, if we keep the stress level at a low stress for comparative to the tension test, we will see the moving part can run infinite number of circles. Or we generally use 10 to the power 6 cycles, a life cycle of a member. This is known as, this can be only found out by fatigue testing. And when you come to the fatigue test, we will encounter dynamic loading conditions, and we will see how the resistance of the materials against dynamic load can be measured. This will be continued from lecture 2, 3, etc. for all this testing one by one. Thank you.